There you are now. Welcome back to the workshop. So on today's video, we're going to sort a problem out for Cole over on Classic Mini DIY. Cole rang me about 3 or 4 weeks ago now, thanks to massive shipping delays. That'll all become clear on why that is in a few minutes. With a problem. He's building a turbocharged A-Series Mini. The engine has gone into the car. He's getting ready to put everything together. And he said, look Paul, I'm trying to crank this engine over, and sometimes when I crank it over, he said, it cranks over but it makes a horrendous noise. Other times when it's cranking over, he said, it sounds like the gear is just grating. And he said other times it actually locks solid and won't crank at all. So I was thinking about this, and he said, look, he said, this isn't straightforward. I've already had a good bit of problems with starter motors on this engine already. He said the ring gear, he has an RTS clutch, one of the twin plate Verto clutch systems. He said, oh, I had already to get the ring gear changed from a pre-engaged ring gear to a inertia type ring gear. He said that didn't solve the problem. I changed from a high torque starter motor to an inertia type starter motor. That didn't solve the problem. He said, I'm kind of at a loss, what do you think? So I said, look, let me think about it for a bit. And then I got to thinking, do you know what? I wonder if it's mismatched components causing this problem. So I did a video chat with him on WhatsApp and said, look, show me what you have. And he said, well, actually, I have the drop gear housing from maybe an Austin America. I have the gearbox from an A+ engine. I have an A-Series block, and I have the RTS Verto flywheel. So I said, okay, we need to do some measurements. So I want to show you what the problem was, but before I do that, I want to just explain a couple of important clearances here. So I have an engine here that I just pulled out of the shed to show you some of this detail on. When you hear me talking about drop gear housings, I'm talking about this aluminium housing here, and it's joining the gearbox and the engine together, and it houses the flywheel. It has a couple of important duties to do, but one of those is mounting the starter motor in such a way that it can engage with the ring gear. That mounts through the starter motor mounting hole, which is over here. So there's the ring gear now from this side, and the starter motor comes in from here. On the starter motor is a pinion. That pinion can move one of two ways. On a pre-engaged starter motor, the pinion moves from here in to contact with the flywheel, and on an inertia starter it comes from out there into the flywheel. The distance that can move is very specific. The starter motor can only throw the pinion gear so much. That distance is between the ring gear and the face here that the starter motor mounts onto. On some different engines, what can happen is that flywheel can end up in a different position relative to the face of the starter motor housing, or this mounting bracket here, this flange. If it does, what can happen is a couple of different things. You can get an overthrowing starter motor, which is where it tries to send the pinion too far, and when it does that, it's going to go past the ring gear and get wedged. Or you can have an underthrowing pinion, which is one that doesn't quite make it into the ring gear, or makes it just ever so slightly into the ring gear and doesn't actually engage. So what I asked Cole to do for me was, I asked him to measure the distance between this flange here and the front edge of that ring gear. I then also asked him to measure the width of the ring gear for me. Anybody who was keenly watching my Instagram stories the other day seen me put up a measurement, I think it was on Thursday last week, and those were the measurements that Cole gave me. The measurement between that starter motor mounting flange and the ring gear was 35.5 millimeters, 35 millimeters and change. And the width of the ring gear was 10.8 millimeters. We ordered a starter motor from a supplier, and unfortunately it got lost into the transit nightmare of Brexit and England and Ireland and all the rest of it, and we've been waiting weeks and weeks and weeks, and the starter motor didn't come. Mini Spares absolutely nailed this. I contacted Mini Spares on Monday, asked them to send me a starter motor. They put one in the post, and I had it here on Thursday, which to be honest with you, is just fantastic. 4 days turnaround, nailed it. So we have a starter motor, we're ready to solve this problem for Cole. So the starter motor that I ordered them is one of the Powerlite high torque starter motors. These guys are the business. There's a particular reason why I chose this as well, and that is because these starter motors allow me the ability to change this face here. This face here will decide where that pinion ends up. So I can change how much clearance there is between that starter motor going in and coming out and going back and forward. I'll explain more about that in a minute. So yeah, these Powerlite starter motors are the business. So the first thing we have to check is how far out does this pinion gear go? So let's pull the pinion gear out as if it was cranking over the engine, and we're going to wedge it out there just with that little nut. So that's the pinion gear fully out. So what we can do now is we can measure the distance between the front edge of that pinion gear and where it would sit on the mounting face of the pinion gear. We know that we need the distance between there and the center of that gear to be, well, let's think about it. Cole says the face of the flywheel is 35 millimeters away from the mounting flange, and the ring gear is 10 millimeters wide. So if we go half the width of the ring gear, 5 millimeters, and 35, that gives us 40. So what we know is we would like the center of that gear there to measure 40 millimeters away from the mounting face. Now it's going to be hard for us to measure that mounting face, so let's first of all figure out what that little recess there is. So we'll take that measurement. Let's see now. Zero our calipers, and we get 38.7. So we write our 38.7 down. 38.7 millimeters. Sorry, what am I talking about? 3.7 millimeters. 38. 3.7 millimeters. So that's the width of that reset there. There is 3.7 millimeters. Now let's check and see how far away from the front edge of that flange the ring gear ends up. So I've got 33.8 millimeters. So 33.8 millimeters. So we can call that sort of 34. 34. And then we add our 3.7 onto that. So we get our, we're getting an engagement there of just shy of 38 millimeters, which is absolutely no good. That puts us only 2 millimeters engaged into the flywheel. And that, I suspect, is exactly what Cole's problem has been. I reckon that his ring gear has only been, or his pinion has only barely been catching the ring gear, either from the inertia side or from the pinion side. And because it's only barely catching it, what's happening, of course, is that it is skipping over the gear and not being able to crank it. It would probably crank it with the plugs out, but it's not going to crank it with the plugs in. So what can we do to aid this? Well, we need to find 8 millimeters in this to get this sitting where we want it. Unfortunately, I'm not going to be able to machine back this housing by 8 millimeters in order to get that starter motor to move further in, because if I skim 8 millimeters off this housing, well, let's see what it is. It's probably only 10 millimeters wide. It would leave only 2 millimeters of aluminium, and that would leave this housing too weak. But as I look at this starter motor, what I'm seeing here is that there is quite a recess back here. So what I'm thinking is, let's strip off this plate and see what we have, and maybe what we can do is get that plate itself to move further back onto the starter motor. So if I can get that plate to move further back onto the starter motor, say maybe 3 millimeters, and then we can machine this outside flange back maybe 5 millimeters, then what we'll end up then with is gaining our 8 millimeters that way, which is what Cole is going to need to get his starter motor to engage properly with his ring gear. So let's just see whether that's going to be possible. So this is the reason why I chose one of these starter motors as the option. Also, Cole's building a Turbo Mini, and as I said to him, one of these high torque, high speed starter motors is almost essential, because it'll allow them to have great starting capacity without needing a huge big battery and you know, loads of torque. So these starter motors, these Powerlite starter motors, are fantastic for it. They work really, really well for it. And the engineered design of them is just perfect for what we want. So let's see if we got a little hammer just to tap this housing off. Brilliant. Okay, this is exactly what I was hoping for. So the way this is mounted is there's a recess here machined into the back of this aluminium flange in order to let that sit on there. What we can do is we can increase the diameter of that recess there to allow this whole thing sit further onto that starter motor. If we can get 3 millimeters out of it there, and then we can mount this flange in the lathe and get another 3 or 4 millimeters out of it here. What that'll mean is when this pinion comes out, then it should give much deeper engagement. Are we likely to get it to go absolutely completely? I think what we're going to end up getting it to do is probably just sit flush with the edge of the flywheel for him. But you know what, that'd be fine. That'd give us full tooth engagement on the ring gear, and I think it'll work perfectly fine for him, and I think it's going to solve his problem. I think what we'll do so is we'll get this mounted up in the lathe, do a few calculations, and start machining this for coal. Okay, we're over at the lathe now. I've put the little small 3-jaw chuck in the lathe. It's mounted on a taper center. So if we look down here, what I'm doing here, I've taken a couple of light passes just to start bringing in the diameter. So what I'm doing is I'm slimming down this flange. So I've taken probably a millimeter and a half or 2 millimeters off the flange. I'm going to take about another 2.5 millimeters off it. And then I'm going to just check also to make sure, because what we're now starting to get is we're starting to get a kind of protrusion out here, and we might have to take a little material off this face as well, because it may not go all the way through the starter motor hole, or it may not easily go through the starter motor hole. So because there might be a recess in there, so I'm going to go over and check that on the flywheel. But before we do that, let's take another couple of passes off this and bring it down by another couple of mil. So where are we at there? So we're at 7.7 there, so we'll do another 2 passes and see where that brings us. Just come in, touch off there, and on the dial gauge we'll bring it over a mil. The material that they have used here, it is tough aluminium. I'm going to say HE30 or something like that. Not the nicest material to turn ever, but I suppose their interest will be that it's strong. Let's take another 1 mil pass. Okay. Let's see, where does that leave us now? So we're in there now, just in at 7. So I'm going to take 1 or 2 more passes, and then I'll show you how I'm going to set this up in the reverse direction to do the turning on the other side, and also we'll check it in the drop gear housing. Okay, so I have this set up in the lathe here. I flipped the flange over. I squared up the face off of the original machining in the 3-jaw within a couple of 10,000ths. So I'm more than happy with it. What I've done now is I've started to do a recess here, and the recess I'm doing there is to allow for the outside diameter of the starter motor, this kind of machined surface that they have here, to sit into the flange, so that we can get this starter motor to go further in, or to engage more, as I said, into the flywheel. So this is not actually a accurate machine surface. I've checked it at the top here. It comes in at about 84 millimeters. Yeah, it's 83 point. So we jumped into inches there. It's 84 millimeters there at the very top. Get that measurement again. Yeah, 84 there, but then if I go down a bit further, I get into about 86. So what I'm thinking is, I have to go 4 millimeters in here. I'm thinking I'm going to take a taper turn back out on that edge there so that it ends up back at about 84, 85. I'm conscious of trying to keep as much meat into this flange as I can because I want to try and keep it as strong as possible. While I'm not worried, it is a high torque starter motor. It is only held on 2 bolts, and I don't want the starter motor to start flexing away from the flywheel. So if we lose the strength in that flange, what could happen is, as the engine starts to crank, the starter motor might want to flex. It might want to drive itself out of mesh. The result of it doing that would be that it would start to heavily wear the ring gear, and then it again eventually start to slip and give problems. What I think we might do is, we'll test this out. We'll get Cole to watch it carefully and see how it goes. And if we start getting flexation or problems, then we might remake this flange in steel. So we'll get a piece of 15mm wide plate steel and we'll remanufacture the flange in steel. And that would definitely knock this problem out. But as a problem solve and a solution, this could still solve the problem. So a little bit more turning to do here in order to get this where we want it. We're turning across here. We've a bit of tool chatter. I have a lot of stick out here because I'm on the boring bar. I might change back to the face cutter because, as I said, I'm starting to pick up a lot of tool chatter, and that's going to be there. So change it back around to the face cutter. I'm using a very specific insert here for this aluminium because it's high carbon. Not high carbon, there's no carbon in aluminium, Paul. It's very hard aluminium, HE30 maybe, I think, or something like that. It's not free cutting anyway. Aluminium can sometimes be that way. I could probably do it running this lathe a little bit faster, but I really don't want to run it any faster with the way I'm work holding here in the chuck. So I think we'll just see, can we access it with this cutter? And if we can, then that might well just solve our problem. And I think we might just get away with it on this cutter. A lot of cross slide out, but that's okay if we get the stiffness in the cut, which I think we're going to get here now. Yeah. Okay, let's try that and see if that gets rid of our chatter. Oh yeah, that's much nicer. Going to need to grind a little bit of relief on this cutter here. Give me 2 minutes. Okay, I've ground a little bit of relief into that cutter and it is cutting so much nicer now. It's fantastic. That little bit of screech at the end, I have the cutter set up in such a way that it is actually going to put the taper that I was talking to you about in the cut by using the side angle of the diamond cutter to literally actually catch out the edge. So we'll get the taper we wanted just with the side relief on its own. Bird's nest coming off there. That's what I was talking about, that material. It's not cutting particularly nice. It's bird nesting like that because I don't have enough speed in the lathe to break the chip, but that's okay. 2.4. I'm going to go another couple of passes and then we'll move into this cut and do that then. That's our next relief angle. Okay, so we've ground pretty much all of the reliefs now, or sorry, we've turned all of the reefs. Let's take this out of the chuck and try it on the starter motor and see how much clearances we've given ourselves. We're going to break those edges as well. Incidentally, I did try it in the flywheel housing and there's loads of room for that shoulder to go in. So I'm not going to turn that shoulder back anymore because I want to keep as much strength in that shoulder as I can. So let's just try this now on the flywheel and see what we have. Okay, I have the plate screwed back on to the starter motor with the original bolts, and just to kind of give you half an idea how much we've sunk that plate on, you can see the original bolt now is sticking out the back here, so we've really set that plate back in there deeply. There you can probably just make out, I'll bring it into the good light there, the back cut that we did. So remember I was saying to you that the edge of this wasn't exactly a true diameter, so we just did a back relief on that, so to allow that housing move back. You can also see this stick out here, how much that starter motor is now sticking out through that housing. It was completely flush and now it's sticking out. That's one of the places where we got our measurement. So with that flange turned back, that there measures the thickness of that, or the width of that area there, now measures 7.7 millimeters. So that distance there is 7.7 millimeters. So if I take that from Cole's measurement, which was 35.5, which is the distance between the face here and the edge of the flywheel, if I take that measurement away, I get 27.8. So if I set my calipers at 27.8 and now measure from that face there, it should tell me where my ring gear ends. I just put a mark on the ring gear there with my marker just at the end of the verniers at 27.8. So that means that's where the edge of the flywheel will be now when that pinion gear comes all the way out, as it is there now. So let's measure that and see what that distance is. And to the front edge of that tooth, I'm getting 12 millimeters. Well, 11.98, we'll call it 12. Cole tells me in his drawing that the flywheel ring gear is 10.5 millimeters wide. That means that we are now getting the tooth of that pinion to go past the end of the ring gear 1.98 millimeters, or 1.9 millimeters, so nearly 2 millimeters. Give or take a little bit of room for error and misjudgment, and the fact that that pinion may not be completely out, like that pinion might come another tiny bit out, I think we've really got a good solution to the problem. Just to be sure, I'm going to just try that starter motor in this housing, just make sure that I can actually get it to sit all the way in and flush, which hopefully we can. And there it is, sitting in all the way nice and flush up to the housing. The two bolts can go in to hold it there. It'll sit in there nicely for him. He can connect up, and then the pinion then will be able to hopefully come right out and touch the ring gear. In this case, if it was actually this flywheel, the pinion is actually just about engaging with the ring gear as it is. But knowing his measurement and knowing where his flywheel is, this is going to be perfect. Just on that note, guys, thank you very much for watching the video. This is an unusual video where we solve a problem for a friend of ours, Cole, over Classic Mini DIY. This hopefully will get him out of a jam. This is the kind of stuff that I live for. I love solving problems like this, where you get really unusual situations. I love thinking about them, solving them, getting them there. And it's this kind of stuff I want to get on the channel. I want to get that information out there, because you'll find you can ring the guys that make these starter motors, you can ring any of the suppliers, and they won't have this information readily available, because everything that they make is based off standard settings, not mix matches where you've got a casing off of this, a gearbox off of that, a drop gear housing off of that, an engine off of that, and when they all come together on a different flywheel, things change. And it's this kind of information I want to get out there, because people will have these problems, and like Cole, they'll go around in circles, changing flywheels, changing starter motors, changing ring gears, until eventually they actually get this information. So now we have a repository with this information. I'll go more in depth if people want on how to get those measurements, but it is pretty simple. If your starter motor is not working right for you, get a measurement between the mounting face and the ring gear face, pull your pinion gear all the way out and check to see if that measurement. If you're not getting full engagement, or you're getting too much engagement, well, that might be your problem. Make sure that your pinion is the right count for the flywheel. There's only 2 types in the way there's a Mini. With the inertia type starter motors, it's a 9 pinion. Can't remember off the top of my head what it is for the pre-engaged, but you'll find that on any of the parts supplier websites, or any of that information will be there. Don't forget guys, if you like this video, bang the like button. If you're new to the channel, you are most welcome. Have a look around at some of the other videos we do, and if you like our content, please give us a subscribe. We really do appreciate it. Other than that guys, thank you very much for watching. Head over to Cole to see his video, which will be coming out in the next couple of days, where he puts this into his engine and hopefully gets his turbo fired up. See you guys on the next one.